Hey guys, welcome back to our channel. So today we're going to be talking about the photo theory, photon theory of light and the photoelectric effect. Alright, so let's dive in. So very quickly, some formulas we're going to need to know is the energy of a photon. So energy that a photon contains is proportional, as we spoke in the last video, to Planck constant times the frequency. And I noticed that on the past video I didn't really address what Planck constant was. So that's just a given value, which is 6.626 times 10 to the negative 34 joules times seconds. It's just a constant. Alright, so let's talk about the photoelectric effect first of all. So photoelectric effect. Alright, so what the photoelectric effect means, or the summary, the main takeaway, is just that when you shine light, so when light is shined on something or a metal surface, so when light shines on a metal, this is the word by word definition, on a metal surface, electrons are excited and therefore are emitted from the surface. From the metal surface, of course. Now, I would like to add something in here, which is from my personal experience, mostly metals, because this can happen with other surfaces as well that are not metals, but because metals, if you can recall from chemistry, if not, just you're going to have to believe me on this one, metals have like a cloud of electrons around them, which it gives them a little bit more flexibility to emit electrons when some energy is shown or shined into them. Um, so that's why I'm saying mostly metal surfaces. All right, so that's just the main takeaway of the photoelectric effect. It's just electrons are emitted when you put light or you shine light on a metal surface. All right, so now there are two things that you need to know for the photon theory of light and the photoelectric effect. So the first one is that besides the photon theory of light, there's another concept that was first introduced, which was considered, and it was called the wave theory prediction. I struggled there to spell this, but we got through it. So let's move on ahead. So the wave theory prediction does two things. Number one, it predicted that the higher the intensity given or that a surface is exposed to, so intensity, the higher the kinetic energy will be of the photon, kinetic energy of the photon, and therefore, which will be proportional, as we remember from kinetic energy is 1/2 mv squared. So the higher the kinetic energy, the higher the velocity of the electron ejected. All right, so that's the first prediction that the wave theory does. The second prediction is going to be that frequency has no relationship or is not directly proportional or proportional at all to the kinetic energy of the electron ejected. So only intensity, so the kinetic energy is purely directly related to the intensity of it. So that's the wave theory prediction. So it comes up with this prediction from our formula right here. Energy equals to wave, sorry, not wavelength, frequency times Planck constant. So that's the wave theory prediction. And there is also the photon theory. All right, and this is, as you will find out later in this video, this is what is mostly accepted and what has been shown in experiments to happen. So this photon theory says that in order for there to be an electron ejected from a surface, and so what that will look like is you have a surface, a metal surface. Let me find a gray here. So you have a metal surface and you will have electrons. So all of these theories predict that you will have some type of electrons. So let me just make this here. So you have electrons near the surface of this. And the moment we shine light into them, this light of a given frequency will interact with the surface and it will eject an electron out of the surface with a given velocity or a kinetic energy. That's the photoelectric effect in summary. So now let's go back to the photon theory. What the photon theory says is that the surface has a certain work function. And all the work function really means is that there's a minimum amount of energy required for the surface to let the electron go, which is denoted by W, capital W initial, which just means the minimum amount. So many times you also see just capital W, and this also means the work function. However, this is not the minimum. And it gets a little bit more complicated than this. But the summary is, all you need to know is that W, initial W or W without the little naught, means the work function. So the photon theory says that there's a work function or an energy that has to be met in order for the electron to be ejected. Otherwise, the electron will not be ejected and there will be no kinetic energy. And they express this with the following function, that the energy, or as we can recall, Planck's constant times the frequency, will be equals to the kinetic energy of the outgoing electron plus the work function. So what the photon theory does, it makes two assumptions or two predictions, just in the same way that the wave theory did. Number one, that kinetic energy, if we rearrange this formula right here that we just wrote, is going to be directly proportional to the frequency minus the work function, meaning that intensity has nothing to do with it. So it's the complete opposite from what the wave theory is saying. And number two, the second assumption or prediction that they make is that the higher the intensity, that just means the more electrons you're shooting. It doesn't mean that you're giving them more energy. It just means you're shooting more electrons with the same amount of energy. So the higher the intensity is, you will have more electrons. That's it. So if you have enough energy within those electrons, then yes, intensity will depend or will dictate how many electrons you are allowed to escape the surface. However, if this minimum is not met, it doesn't matter how much intensity you increase, no electrons is going to go out. So the higher the intensity is not proportional to the kinetic energy. So if we add more light, not energy, but light, and we increase intensity, that doesn't mean that there's going to be more electrons flying out of our surface. That's what the photon theory says. And because there has been many experiments done in this, it has turned out that the winner of the case is the photon theory. So, and that's what we see in labs, and hopefully I can record some of these experiments when we're doing them in lab and post them here so you can observe what it looks like or how we are able to identify it. As you shine light, the electrons that go out, if they go out, depend on the frequency. Now, how many will depend on the intensity of the light, but the velocity which they escape does not depend on the intensity. It depends on the frequency. So in the following videos, I'll make some examples, mathematical examples of what all this means. So I just wanted to address the conceptual in this video. So I hope this gives you a little better understanding of what the photon theory and the photoelectric effect is and how it applies to physics. So I hope you guys like this video. Let us know what we can do better, what you want to see us address next. And remember, subscribe to our channel, check us out on Facebook, and remember to like this video. Good luck with your studies.